All right, open up your book to section 9-2. We're on page 444 in your book, and the title of this section is Oblique Triangles, the Law of Cosines. And the objective here is given two sides and the included angle of a triangle. It would also be known as side angle side. Derive and use the law of cosines to find the length of the third side. And the second part of the objective is given three sides of a triangle, that is side, side, side is what that would be known as. Find an angle measure. All right, let's start out with a term here that is in the title of this section, which is oblique triangles. And so an oblique triangle is just a triangle with no right angle. So we're no longer starting out with a triangle that's a right triangle. Rather, it's going to be a triangle that does not contain a right angle. So what exactly is the law of cosines? Well, here is the law of cosines. The law of cosines states the following. And we use this for two scenarios as the objective indicated there. Given side angle side or side 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 is what those abbreviations mean. If you have a triangle ABC with sides A, B, and C. Notice, by the way, the naming convention that we'll use here. The capital or uppercase A, B, and C are going to represent the names of the vertices or the angles of that triangle. And the sides are going to be named by lowercase letters A, B, and C, where side A is opposite angle A and side B is opposite angle B, and so forth. All right, so in triangle ABC with sides A, B, and C, we have the following. A squared is equal to B squared plus C squared minus 2 times B times C times the cosine of A. That right there is our law of cosines. Notice, by the way, when you look at this, that the side A is on the left side of this and the angle A is on the opposite side of this equal sign for this equation. So when you go to set this up, that's the key here, is to consider what angle that you're either looking for, and the side has to be on the opposite of that, or given the side that you're looking for, just realize you have to have the angle that corresponds to that side on the other side of this equation. All right, let's take a look at the proof of where this law of cosines comes from. So to show where this comes from, we're going to actually use the distance formula to do that. So to use the distance formula, we're going to have to plot some points in the coordinate plane. So here's how we're going to do that. I'm going to go ahead and sketch. I'm going to put this just in the first quadrant, but it really wouldn't matter whether this took up the first and second quadrant here to do this. But I'm going to plot 3 points. I'm going to plot 1 point, and the points that I'm plotting, by the way, are the vertices of my triangle. So I'm going to call this vertex A here at the origin. I'm going to rotate my triangle accordingly so I can put another vertex on the x-axis over here, and we're going to name that point B. And then point C could either be in the first quadrant or second quadrant, depending on whether this is an acute triangle or an obtuse triangle here, but it really doesn't matter where I plot this point. I'm just going to name this point out here as point C. And again, it wouldn't make a difference whether I plotted that in the first quadrant or the second quadrant here. We're just going to sketch this triangle then. Draw lines in between these vertices here, and we end up with this triangle right here. And go ahead and label the sides here. The side opposite angle A is side A. The side opposite angle B is side B. And finally, side C is opposite angle C. All right, and then we're going to go through and name the coordinates of each of these points. We've plotted these points in the coordinate plane so that we can use those. The easiest one, of course, is the point A here, because of the fact that it's at the origin, so that's at 0, 0. For point B, that one's not too tough to name either, because of the fact that it's on the x-axis, so I know the y value. And C is telling you how far from the origin you are. So this is at the point C, comma 0. And then finally, point C is just out there somewhere in the first or second quadrant here, so I don't have a way of naming that right now, so we're going to call it just UV. We're going to figure out what U and V are equal to here in just a second, but for right now, we'll call that UV. All right. What I need to do is use a little bit of right triangle trigonometry to help me evaluate to find out what u and v are equal to. So I'm going to sketch a right triangle here. I'm going to drop a vertical down from point C, and I'll mark that as a right angle here. And if I sketch this out there, I have myself a right triangle. And the angle down here is what we're calling A. Again, that point there, vertex A, is naming the vertex as well as the angle. And actually, the point UV that we named up above is actually the side lengths of this triangle that I've got marked here. That is, U is actually this horizontal leg of this right triangle, and V is the vertical leg of that right triangle. And of course, B is the hypotenuse of it. So with that, we can do some let me do this in the same color here, I guess. We can do some right triangle trigonometry with this to find out what u and v are equal to. If I take the cosine of A, the cosine of A is equal to, it's the adjacent side divided by the hypotenuse there, which is B. Or you can even think of it as being a point named in the coordinate plane. We've done this now, but you've got the point UV, and the distance is now B instead of R like we normally have named it. But I can solve this for u. U is equal to B times the cosine of A. If I multiply both sides by B, we end up with what u equals. So that's this coordinate right here. I know what its coordinates are in terms of B and A. That's critical for me, that I can get it in terms of one of my sides and an angle. Do the same thing for V, but we're going to use sine. The sine of A is going to be equal to V over B. So I can solve for V. V is equal to B sine of A. So again, that tells me what the vertical component, the y value there, is equal to for point C. All right, so I started out by saying we're going to use the distance formula to do this. So we've got 3 points here. So the question is, well, what 3 points or what 2 points are we going to find the distance between? And the answer is we're going to find this distance right here between points B and C. In other words, we're going to find out what A is equal to, is what we're going to use the distance formula. And actually what we're going to do is we're going to find out what A squared equals. Rather than writing the distance formula with the square root in it, we've done that before now. We're going to do it again here. So use your distance formula. All right, so with our distance formula again normally would say that A equals the square root of something. But I'm going to square both sides of that. So instead of A equals, it's going to be A squared is equal to something. And instead of being the square root of something, I've squared it, so that gets rid of the square root for me. And so our distance formula just says take the difference in the x values. So I've got u here and I've got c here. So this is u minus c squared. And add on to that the difference in the y value. So I've got v up here and I've got 0 there. So that's v minus 0 squared. You can see I already have this as a squared is equal to something squared plus something else squared, which is kind of close to what I'm trying to come up with for my law of cosine. So this looks like a good starting point. Let's replace u and v with what they're equal to, because I want to get this in terms of just b and c and the angle A. So that's the good thing about what we've done already. I found out that u equals b cosine of A, so I'm going to replace that, b cosine of A minus c squared. And I found out that v was equal to b sine of A. So this is plus b sine of A. I'm going to leave off the minus 0. If you want to write it, you can, but minus 0 is not going to change anything. So we'll just keep that off. All right, the first part of this is a binomial. This binomial here, we've got to square that thing out. So don't forget, when you square out a binomial, you end up with a trinomial. So what are the 3 terms? I'll have a b squared cosine squared of A. And then here's the middle term, minus 2 times b times c times the cosine of A, which if you're thinking about what the law of cosines is, that thing looks really nice actually, because that's part of the law of cosines. And the third term of this, when I square it out, we'll get the c squared plus c squared. All right, I got to square out the last part of this, so b sine of A squared is going to be b squared sine squared of A. All right, let's combine a couple terms here. I see that we've got 2 terms that contain a b squared, this one right here and this one right here. So let's put those out front. In fact, while we're doing it, since they both have a b squared in it, let's factor out a b squared. So I've got b squared times the cosine squared of A. Oops. I want to factor it out of both terms here. and then add that to sine squared, right? When I factor out the b squared from b squared sine squared of a, I'll end up with this. Oh, that turns out to be pretty nice. This cosine squared plus sine squared, that looks like a nice little property we know. Let's put the c squared term next, and then we'll put the minus 2bc cosine of a at the end. Yeah, it looks like we just have one step to get our answer here then. B squared times this cosine squared plus sine squared. Cosine squared plus sine squared is 1. So I can just replace this with just b squared. And then plus c squared minus 2bc cosine of a. Right there is our law of cosines. A squared is equal to b squared plus c squared minus 2 times b times c times the cosine of a. This right here works for an oblique triangle for finding either finding an angle given all three sides, or finding a side given two sides and an included angle. Side angle side or side side side. All right, so you might ask yourself, well, what happens if this is not an oblique triangle? That might be a natural question there that you might ask. Well, what happens if you've got a right angle that we're working with? What happens if A turns out to be the right angle? Well, notice what happens here. If A is a right angle, that means A is 90 degrees. So when you calculate the cosine of A, cosine of 90 degrees is 0. So that means that we'd have the following. If I take a squared and set it equal to b squared plus c squared minus 2bc cosine of a. That's just our law of cosines. This guy right here, cosine of a, we just set up above here. We're letting a be 90 degrees, so the cosine of 90 degrees we said is going to be 0. Which, of course, when you multiply by 0, 2bc times 0 is going to give you 0. So that term just drops right out. It turns out you'll end up with a squared is equal to b squared plus c squared. That formula right there should look very familiar to us. Hopefully we recognize that. That right there is our Pythagorean theorem. Now we can't use law of cosines to prove Pythagorean theorem because we used the distance formula, which is actually where or comes from our Pythagorean theorem. So we've used Pythagorean theorem to use law of cosines. You can't then turn around and try to use it to prove Pythagorean theorem. That would be a circular reasoning. But this does show you that even if A is 90 degrees, even if we have a right triangle, it turns out that law of cosines can still be used here. It'll end up giving us the correct Pythagorean theorem that we know. In fact, you can extend this idea and use it to help you understand a little bit about the angle that you're working with by looking at how a squared is related to the sum of b squared and c squared. The bullet in the middle we just kind of talked about. That if a squared is equal to b squared plus c squared, then a must be a right angle. And the reason it must be a right angle is because of the fact that the cosine of a would have to be 0, so you're subtracting 0 from the right side of that, and that's why it turns out that a squared is just equal to just the b squared plus c squared. But if a is acute or obtuse, it also can be used to help us figure something out, but it's not going to be equality, but rather it's an inequality. So the first bullet there says that if a squared is less than b squared plus c squared, then that means you have an acute angle for a. Now the reason for that is because of the fact that the cosine of a, if a is an acute angle, the cosine of an angle between 0 and 90 degrees is positive. It's greater than 0. So that 2bc cosine of a that you're subtracting off, you got to make, that's got to be a value you're subtracting from b squared plus c squared to finally equal a squared. So that's the reason why I know that if a squared is less than b squared plus c squared, we've got ourselves an acute angle. Careful reading too much into that. Just because you found an acute angle does not mean you have an acute triangle. If you know that you're working with the largest angle, and the largest angle is acute, then you know that it's an acute triangle. So just be careful with that one. The second bullet there for a right angle, if you find that you have a right angle, then you're guaranteed you've got yourself a right triangle. And the third bullet there says that if a squared is greater than b squared plus c squared, then a must be an obtuse angle. Which of course means if you have an obtuse angle, you must have an obtuse triangle. You can only have at most one acute angle, one right angle or one obtuse angle. That's how we can say that about the last two bullets, but not the first one. And again, the reason why it would have to be obtuse is because if you take the cosine of an obtuse angle, that's between 90 and 180, I know that cosine, that'd be an angle that's in the second quadrant. Cosine is negative in that quadrant. And so that's why when I subtract off that negative 2bc times the cosine of A, subtracting off a negative, you're actually adding that quantity on there. So that's why that turns out to be an obtuse angle there. All right, one last thing here that we should talk about, and then we'll do a couple of examples here. This is hopefully an idea that we recall from previous work, but we have a triangle inequality. And our triangle inequality tells us something about the relationship between the sides of our triangle, similar to what we just talked about up above there for the size of an angle, but this right here tells us whether or not we even have a triangle to start off with. So notice that we're not squaring the A's, B's, and C's here. So in triangle A, B, and C with sides A, B, and C, it has to be the case that when you sum up any two sides of that triangle, that turns out to be more than the third side. So A has to be less than B plus C, B has to be less than A plus C, and C has to be less than A plus B. And again, basically what that's saying is any side of your triangle has to be less than the sum of the other two sides. That's our triangle inequality. All right, let's take a look at a couple of examples here using law of cosines. All right, example 1 here on page 446. And I guess it says in the title here that this is going to be side angle side, so I guess we've spoiled that if we're going to try to figure that out. But nonetheless, let's take a look what they've given us here. Triangle PMF. Triangle PMF, you have angle M is equal to 127, side P is equal to 15.78, and side F is equal to 8.54. All right, and those are both in feet, so we'll have to make sure we include units here in our answer when we get done. And they want us to find the measure of the third side, side M. All right, so what I'd suggest that you do here is start out with a sketch of what this triangle looks like. They gave us an angle, so we know it's an obtuse angle, so it's going to be an obtuse triangle here. You can use that to help you with your sketch, but even if it's not an accurate sketch here, I guess I can do this. It's okay. It doesn't have to be exactly right. You don't need to get a protractor out here and measure this angle and make sure it's 127 degrees. Okay? Just draw yourself a triangle. So this is angle M, that was the 127. They also told us that side P was equal to 15.78. Let's call P this point up here. So this is going to be the 15.78 feet. And we'll call this F, and they said that F was equal to the 8.54 feet. So this is 8.54 feet. All right, so those are the two sides and the included angle. This right here is side angle side. That's what it's referring to up here, side angle side. All right, so we're trying to find out what M is equal to. That's the side opposite the angle that they gave us. And again, when you go to set up your law of cosines, I'm going to go ahead and write it out first in terms of the variable names that they've used in this problem, but the side that we're looking for and the angle that we have to be on opposite sides of each other. So it's going to be M squared is equal to P squared plus F squared minus 2 times P times F times the cosine of angle M. All right, all I've done is taken law of cosines and replaced it with the names of the side lengths and or the sides and the vertices in this triangle. All right, so let's go ahead and write down what we know here then. Side P, they told us, was the 15.78 squared, plus F, they told us, was the 8.54 squared, minus 2 times the P, which is 15.78, the F, which is 8.54, and the cosine of the angle, which is 127 degrees. All right, this is what M squared is equal to. I guess keep that in mind that when we go to solve to find a value here that you've got M squared. In fact, maybe I'll write that down again here. M squared is equal to this. That's not the question they're asking us for. They want us to find out what M equals, but just realize we've got that extra step there to find out what M equals. Take the square root. Let's grab our calculator and try this out here. All right, so with your calculator, let's a second here and get my calculator connected. All right, so with your calculator, let's go ahead and do that calculation here. We had 15.78 squared and plus the 8.54 squared, and then minus 2 times the 15.78 times the 8.54 times the cosine of 127. Make sure you're in the right mode here. I'm in degree mode, so we're all set, but double check that on your calculator. And there's the 484.143. Now remember, that's what m squared equals, so I'm going to go ahead and calculate the square root of that as well while I'm right here, because that's the number I'm looking for. I want to find out what m equals, and that is our value of m. Let me grab a picture of that. All right, so we have m squared is equal to 484.143. All right, make sure you got 3 decimal places. You can either round or truncate, but make sure you got 3 decimal places of accuracy. And again, that was not the question. The question is, what does m equal? So we're going to take the square root of both sides of that like we did, and we got 22.003. And again, this was measured in feet, so make sure you include units here in your answer when they're given to you in the problem. So there is the side length of m, 22.003. You'll notice, by the way, that on that triangle, side m is the largest side. And notice that's because of the fact that the angle m is 127 degrees. That would be the largest angle. The largest side is going to be opposite the largest angle, smallest side opposite the smallest angle, and so forth. All right, let's take a look at another example here. Look at example 2. This time here, this again says side, side, side at the top, so I guess that a little bit of a spoiler here for us, but nonetheless, they're going to give us 3 sides here, and we're going to try to find out an angle, it looks like. So they tell us in triangle XYZ that x is 3 meters, y is 7 meters, and z is 9 meters. So again, give yourself a sketch of a triangle here to work with. And I don't know really anything about the side lengths and how that relates to the angle measurements. So it really doesn't matter how accurate of a sketch you have. Just label it X, Y, and Z and fill in the numbers they gave you. So they told us that X was 3 meters, so I'll put that in over here. And Y was 7 meters. And Z was 9 meters. And again, the question that they're asking us here is find the measure of the largest angle. So I just mentioned this at the end of the previous problem there. But the largest angle is going to be opposite the largest side. So the largest side, of course, is our 9 meters. So the angle Z is the one that we're looking for here. They could have just told us that, but they said in a slightly different way and just said find the largest one. And so you have to know which one's the largest. All right, so the key here for us is that the angle that you're looking for, which in this case is Z, and the side length that you're given there have to be on opposite sides for your law of cosine. So I'm going to write out that 9 squared is equal to 3 squared plus the 7 squared minus 2 times 3 times 7 times the cosine of Z. And let's go ahead and solve this for Z. We've solved equations, well, maybe not equation like this, but we've solved equations that have cosine in it before and solved them for the angle. So that's what we're going to do here. Let's first get rid of the 3 squared and the 7 squared. I need to move that over to the other side. So I'm going to write this as 9 squared minus 3 squared plus, oops, it's going to be minus though, right? When I subtract both of those, it'll be minus 7 squared. And that's equal to a negative 2 times 3 times 7 times the cosine of Z. You could, of course, grab your calculator and find out what these constants turn out to be on each side here. I'm going to leave it like this for just one more step here, and then we'll evaluate these. The next step of this is to get rid of that coefficient in front of the cosine here. So this guy right here, let's divide to move him to the other side. So we get 9 squared minus 3 squared minus 7 squared, and that's all divided by a negative 2 times 3 times 7. And that's what the cosine of Z is equal to. All right, so let's calculate these two values here. Let's just write this as a fraction, but let's calculate the numerator and denominator. If it turns out to be a nice fraction, we could write it as a decimal quantity, but let's see what we end up with. 9 squared is 81. Minus 3 squared minus 9 is going to give us 72. And then minus 7 squared minus 49. 72 minus 49, that sounds like 23 there. So you have 23 in the numerator. And then 2 times 3, that's 6 times 7 is 42, and it's the opposite of that, so it's going to be a negative 42. All right, so we have the cosine of z is equal to this quantity right here. So we can solve this. We've solved equations just like this many times now. When you go to solve this, remember we use arc cosine to solve these equations. So we have z is equal to the arc cosine, I'm going to put the negative out front, negative 23 over 42. Now, replace arc cosine with what it's equal to. So z is equal to, it'll be plus or minus the cosine inverse of a negative 23 over 42. And then plus 360 times n. We're working in degrees here, so it's going to be plus 360 n. All right, so we can find out what plus or minus to pick, and we can find out what value of n to pick if we just go back to the original equation here. This guy, well, I shouldn't say the original, but this equation here at the top, and graph it along with the value that we're setting it equal to on the right side and find the solution that we're looking for. So I know what cosine looks like. We can sketch that. You could also grab your calculator if it helps you to have your calculator to help you out here, but I think we can sketch this without our calculator. That's what the cosine function looks like. Here is 0. Here is 360. And we're setting it equal to a value of negative 23 over 42. Negative 23 over 42. Well, if it was 21 over 42, that would be a negative 1/2. So that's a little bit further down here than negative 1/2. So that'll be somewhere about right here, we'll say. It's a negative 23 over 42. All right. So we've got a few solutions there that obviously that we could come up with. We want the solution for our triangle that we're working with. Well, I guess if we're working with a triangle, if this is 180 where I hit this low point at, I'm only looking for answers then that are between 0 and 180. The smallest angle that I can have has to be 0, and the biggest I could have is 180 if I'm talking about angles in a triangle. I guess really the only domain here that makes sense is from 0 to 180. So actually, that means there's only one solution here, right? This is the solution that we're looking for. So here's where n is equal to 0. And we move forward from there to find this solution here, which is our positive cosine inverse solution. So we'll use n equals 0, and we're going to use the positive part of this. Which actually, if we think about what our range of our cosine inverse function is, the range of cosine inverse, the range of this guy right here, is between 0 and 180. We know that cosine inverse of any quantity is between 0, let me just write it as the cosine inverse of, we'll call it x here, is between 0 and 180. Cosine inverse gives me an answer that's between 0 and 180. Which, if that's the case, then I always know that I'm going to pick the positive choice here. And I'm always going to let n equal 0 here to get an answer that's between 0 and 180. So really, if I'm solving these problems here for finding angles in a triangle, I don't have to worry about the plus or minus. I don't even have to worry about the plus 360n here then anymore. I'm always going to pick the positive choice for cosine inverse, and I'm always going to pick n equals 0. So we can actually kind of shorten our work there a little bit when we're solving these problems to find an angle in a triangle. Now that's the key here. We're not changing anything else we know or anything we've learned previously about arc cosine. All we're talking about is if we're solving for an angle in a triangle, this is how we can do it. So the question then is, what does z equal then? What does z equal? Let's grab our calculator and evaluate cosine inverse of that quantity. Get rid of the previous problem there. So if I take the cosine inverse of a negative 23 over 42, again, we're in degrees here. Make sure you're in degrees on your calculator. And we get 123.204, I guess. Let me grab a picture of that. All right, so 123.204 degrees. There's our value for Z. All right, so that was our angle of the measure of the largest angle is what they asked us for there. All right, let's look at one last example here. Example 3 here on page 447 says, suppose that the lengths of the sides in example 2 have 3 meters, 7 meters, and 11 meters for X, Y, and Z. So it looks like they just changed the measure of side length Z. So let's draw our triangle here again. So this was our X, this is our Y, and this is our Z. And so the 3 meters for X is still the same, 7 for Y, but now 11 for Z here. All right, and the question is, what is the largest angle? What is the measure of Z? So they could have asked us for the largest angle this time, but they just said, what's Z here? So we're looking for angle Z, which again, notice that the opposite side of that is what's going to have to be used when we go to calculate this. Now, before you start this problem, you might recognize that there's an issue with this problem. And it comes about because of our triangle inequality. Our triangle inequality says that the sum of any two sides of our triangle has to be bigger than the third side. Well, notice what happens when I take 3 plus 7. 3 plus 7 is supposed to be more than the third side, but it's less than it. This is a problem. We don't even have a triangle. So if you recognize that right here at this point, you're done. There's no work to do. There's not even a triangle. But let's suppose maybe we didn't recognize that. So what happens? Well, let's suppose we start out with law of cosines and set this up the same way, but it'll be 11 squared this time is equal to 3 squared plus 7 squared minus 2 times 3 times 7 times the cosine of angle Z. Go through and solve this the same way. You're going to subtract the 3 squared and the 7 squared. And then divide by that constant in front of, or the coefficient in front of cosine of Z. So we've got 11 squared minus 3 squared minus 7 squared, and it's divided by a negative 2 times 3 times 7. That's equal to the cosine of Z. And now let's calculate what the numerator is. We've already done the denominator, so we should be able to write that one down. That was the negative 42. Let me write cosine of Z here is equal to 11 squared is 121, minus 9 is going to be 112, and then minus 49 is going to give us 63 there, I think. Double check that. I think that's the right answer there. Over a negative 42. 349 is 112, yeah. 63 over negative 42, which maybe at this point you also recognize, well, that's going to be a bit of an issue because this guy right here, I might not know exactly what he's equal to, but that's definitely more than 1. And I know the cosine function has a range between negative 1 and 1. Cosine of Z has to be between negative 1 and 1. Again, if you catch that at this point, you're done. Just say, well, there's no solution to this. If you don't, you can move on to the next step here, and you can say, well, let's find out what Z equals. Let's take the cosine inverse of this 63 over negative 42. And again, maybe at this point you recognize you got a problem because the domain of cosine inverse is the same as the range of cosine that we have up here. And so I can't plug in a value of that's more than, I guess in this case, less than a negative 1. I'm going to have a problem here. But even if you still don't recognize it and you grab your calculator, our calculator is going to let us know that we've got an issue because our calculator is going to say, wait a minute, you can't take the cosine inverse of a quantity like that. Cosine inverse of 63 divided by the negative 42 gives us a domain error. Can't do this, okay? So even if you make it all the way to this point here, your calculator is still going to tell you that there's no solution to this. So it's okay if you didn't recognize it from the very first step. Just means you did a little extra math that you didn't need to, but this has no solution. At some point in time, you're going to find that, even if you get all the way to the very last step. All right, that right there is the end of Law of Cosine, section 9-2.